Graphical viewpoint of functions. Suppose we are given any graph, any function graph. So suppose this is a graph of a function fx. So how we make this graph? So every point, there are, first of all, there are infinitely many points on this graph, because this graph is going up, there is an arrow going up on both sides. So there are infinitely many points on this graph, and we are connecting all these points. So what are these points? So these points are in xy plane. So these points, we can write down the position of every point in terms of ordered pair, where the first coordinate represents the x value and the second coordinate represents the y value. In other words, this is the input and y is the corresponding output. So suppose this point is 1 and this is also 1. So what that means? That means when you input 1 in this function, the output is 1. When you input x in this function, the output is y. If you know the function, suppose f of x is equal to x squared. So this is a parabola. So suppose this is a function f of x is equal to x squared, and this is the graph. And if you are asked this x value is 2, find its corresponding y value. So what will be this value? So we are looking for this value. In other words, we are asked when x is equal to 2, find the corresponding y. So in other words, we are looking for the output when you input x. When you input 2, we are looking for the output when the function is defined as x squared. So what we have to do, we have to evaluate our function, because we know that our input is now 2. We are evaluating the function at x is equal to 2. Replace x with 2 on both sides. We get 2 square 4. So the output is 4. So this value will be 4. So every point on the graph of a function represents the input-output ordered pair. If you know the input coordinate, you can find the corresponding output by evaluating the function at the given input point. Okay, if you are given a function, how will we can say that the given function is a given graph is a function graph or not? For example, suppose we are given few graphs and we have to decide if the graph is a function graph or not. So we have a vertical line test. Vertical line test to test a graph is a function graph or not. So what this vertical line test is saying, the vertical line test is saying draw a vertical line anywhere in the graph. If it touches the graph only at once, then it is a function graph, like this. Every vertical line here in this graph touch the graph only at once. So what that means? That means for one x value, there is only one corresponding y value, one input, one output. For this graph, let's see, for this x value, the vertical line is touching the graph at 2 points. That means for one input, we have two different y values. So in other words, x has two different outputs, xy1 and xy2. So one input has two different outputs. So this is not a function graph, because we have a restriction for the function that only those relations are function in which one input has exactly one output. So let me write down here the vertical line test. So draw a vertical line anywhere in the graph if it touches the graph more than once, then it is not a function graph. if it So first graph is a function graph. So it is a function graph. And you can say that this graph passed the vertical line test, and second graph is not a function graph because it fails the vertical line test. It touched the graph more than once. This is also a function graph because the vertical line touched the graph only at one. So that means one x value has only one y value, corresponding y value, one input, one output. So this is how we test if the given graph is a function graph or not. The next one is the domain and range of the function by looking at the graph. Domain and range. So we know that domain is all the inputs or x values, and the range is the outputs or the y values. So if we are given a graph of a function, suppose this is the graph of the function. So we will see the part of x-axis covered by this curve. Part of x-axis covered by the graph, that is the domain of the function. For example, in this graph, the graph starts from here and go all the way in this way because there is an arrow and there is a solid dot. So that means it covers the x-axis this side everywhere starting from -2. So you will say that domain of this function is -2 to infinity, and -2 is included. Similarly, range of the function, range of this graph, function graph, is the part of y-axis covered by this graph. Part of y-axis covered by this graph. If we look at this graph, you see that this much y-axis is covered by this graph all the way up. It will go all the way up because the curve is going up. But when it is below 1, 0 or negative y values, those are not covered by this curve. So the range of this graph is 1 to infinity, and 1 is included. So this is how we look at the graph of the function and see how much x-axis is covered by the curve of that graph, and how much the part of y-axis covered by that graph, and that's how we decide the domain and the range of the function. Thank you so much.